This exciting possibility has sparked the curiosity of scientists around the world, eager to learn more about HD 20794d, a newly confirmed super-Earth orbiting a Sun-like star within its habitable zone. This discovery opens up new doors in the search for alien life and could significantly impact our future space explorations. In this video, we'll dive into how this planet was discovered, what we know so far, and what it could mean for humanity's quest to answer one of science's greatest questions: are we alone in the universe? The story of HD 20794d began in 2022 when Michael Crenier, an astronomer from the University of Oxford, detected an unusual signal while analyzing archived data from the HARPS, high-accuracy radial velocity planet searcher, spectrograph at the Silla Observatory in Chile. The signal, though faint, suggested the presence of an exoplanet. However, it was on the verge of the instrument's detection limits, making it difficult to distinguish from noise caused by stellar activity. Rather than dismissing the signal, Dr. Crenier and his international team of researchers dug deeper. They cross-referenced the data with over 2 decades of observations from not only HARPS but also from the espresso spectrograph, another powerful instrument located in Chile. As they sifted through this wealth of data, they began to notice subtle shifts in the star's light spectrum, revealing the gravitational tug of an orbiting planet. Still, confirming the planet's existence was no easy feat. The team had to carefully eliminate distortions and filter out any noise to ensure the signal wasn't a false positive. After years of meticulous analysis, they finally confirmed the presence of HD 20794d. So, what makes HD 20794d so fascinating? First, there's its location. This super-Earth orbits a G-type star, very similar to our Sun, in the constellation Eridanus. At just 20 light-years away, it's relatively close by in cosmic terms, which means that future space telescopes could study it in much greater detail. But it's not just its proximity that's so intriguing, it's the planet's position within its star's habitable zone, the region where conditions might be just right for liquid water to exist. However, there's a catch: HD 20794d follows an eccentric orbit, unlike the nearly circular orbit of Earth. This elliptical path means that the planet's distance from its star changes significantly over the course of its year. When the planet moves closer to its star, the heat could be intense enough to evaporate any surface water, leaving the planet dry and barren. But when it drifts further away, temperatures could plummet, freezing any remaining water into ice. The question is, could HD 20794d maintain liquid water despite these dramatic temperature swings? If the planet has a thick, dense atmosphere, it might be able to regulate these temperature fluctuations, creating stable conditions for liquid water. But without direct observations of its atmosphere, we can't say for sure. Let's talk about its size and composition. HD 20794d is classified as a super-Earth, meaning it's significantly larger than Earth, with about 6 times our planet's mass. The big question, however, is whether it has a solid, rocky surface like Earth or if it's more like a mini Neptune with a thick, gaseous atmosphere. If the planet has a rocky surface and a stable atmosphere, it could provide Earth-like conditions. But if it's mostly composed of hydrogen and helium, like Neptune, it could be far less hospitable to life. One of the exciting possibilities for the future is that advanced telescopes might be able to analyze the planet's atmosphere for biosignatures, chemical signs of life. Gases like oxygen, methane, and carbon dioxide could reveal whether the planet is potentially habitable, and detecting these could lead to one of the greatest breakthroughs in human history, confirming that we are not alone in the universe. But the road to understanding HD 20794d, and other exoplanets, isn't without its challenges. The elliptical orbit of HD 20794d means that its distance from the star fluctuates wildly, potentially creating extreme temperature shifts. A thick atmosphere could help stabilize its climate, but without one, habitability may be out of reach. There's also the question of geological activity. On Earth, volcanic activity and a dynamic interior help regulate the climate and maintain conditions that support life. If HD 20794d is geologically active, it could replenish its atmosphere and stabilize its environment. But if the planet lacks an active interior or a strong magnetic field, stellar winds could gradually strip away its atmosphere, making life increasingly unlikely. HD 20794d isn't the only exoplanet making waves in the search for life. Other planets have sparked interest due to their potential for habitability. Proxima Centauri b, just 4.2 light-years away, is the closest known exoplanet in a habitable zone. But it orbits a red dwarf star, which emits intense radiation that could potentially strip away its atmosphere, making it a less likely candidate for life. The TRAPPIST-1 system, about 40 light-years away, features 7 Earth-sized planets. 3 of these, TRAPPIST-1 E, F, and G, lie within the star's habitable zone. However, these planets are tidally locked, meaning one side always faces the star while the other remains in perpetual darkness. In theory, a well-balanced atmosphere could mitigate this problem and stabilize conditions, but that's still to be seen. Similarly, Kepler 442b, located 1,200 light-years away, is considered one of the most Earth-like exoplanets discovered so far. It receives about 70% of the sunlight that Earth does, which suggests temperatures that could support liquid water. Another contender is TWA 700d, a rocky exoplanet about 100 light-years away that orbits a quiet red dwarf star. Its relatively stable environment and favorable conditions could increase the likelihood of habitability. So, what comes next in the search for life? The next big step is figuring out whether any of these exoplanets actually harbor life. Upcoming telescopes like NASA's Habitable Worlds Observatory, the European Extremely Large Telescope, ELT, and the Life Finder mission will play a key role in this. These instruments will focus on analyzing the atmospheres of distant planets in unprecedented detail, searching for biosignatures, gases like oxygen, methane, and carbon dioxide, which could point to biological activity. One of the most anticipated missions is LEA, a proposed space telescope capable of directly imaging Earth-like exoplanets. Unlike the James Webb Space Telescope, JWST, which uses indirect methods like spectroscopy, LEA would allow astronomers to directly observe exoplanets and study their atmospheres in extraordinary detail. This could bring us one step closer to detecting life elsewhere in the universe. But there's still a major hurdle in the way: the vast distances between us and the exoplanets we want to study. Even Proxima Centauri b, our closest neighbor, is a daunting 4.2 light-years away. With current propulsion technology, this distance is nearly insurmountable. All of our observations so far rely on indirect methods, such as studying how a planet's atmosphere interacts with starlight. While powerful, these techniques have their limitations, and the results can sometimes be ambiguous. Additionally, we face the challenge of distinguishing between biological and non-biological sources of gases. Many gases associated with life, like methane and oxygen, can also be produced by geological or chemical processes. For example, methane can be produced by volcanic activity, and oxygen can accumulate in an atmosphere through processes like photodissociation, without any life being involved. The future of the search for extraterrestrial life looks incredibly promising, but it also comes with some profound philosophical questions. If we do detect life elsewhere, it could fundamentally change our understanding of our place in the cosmos. Could microbial life exist on a nearby exoplanet or within our own solar system? Or could intelligent civilizations be out there, just beyond our reach? This search also raises the famous Fermi paradox, which asks, if life is common in the universe, why haven't we found any evidence of it yet? Perhaps life is rare, requiring an extraordinary set of conditions, or maybe advanced civilizations self-destruct before they can explore the galaxy. Alternatively, extraterrestrial civilizations may be deliberately avoiding contact or be too advanced for us to detect. The discovery of extraterrestrial life, whether microbial or intelligent, would be the greatest breakthrough in human history, reshaping not just science, but philosophy, religion, and geopolitics. As our technology advances and we extend our reach into the stars, the question of whether we are truly alone could soon have an answer. Whether that answer comes in the form of simple microbes or intelligent beings, the search for life continues to fuel our curiosity. As we look up at the stars, each new discovery brings us one step closer to understanding the most profound mystery of all: are we alone? Thank you for joining us on this exciting journey of discovery. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on the latest space, science and astronomical breakthroughs. Hit the notification bell to stay updated on future videos. And let us know in the comments, which exoplanet do you think has the best chance of hosting life?